pH and conductivity sensors. In this experiment, we will study a pH simulator and a conductivity simulator. The theory, procedure, review questions are already there, and users are advised to read theory and procedure before performing this experiment. So if you want to see the simulator of pH, click here for pH simulator. The simulator will get open, and level 1 is meant for calibration. For pH electrode, there is 2-point calibration wherein the pH value is 4 and 9.2. Standard solutions are given. So if you immerse the pH electrode into pH 4, you will get this output. 4 is 177 millivolt. And if you immerse the pH electrode into 9.2, minus 130 millivolt would be generated. Now if you see the graph, you will find at 0 pH 414 millivolt and minus 414 millivolt at 14. So at 1 pH 414 and at 14 pH minus 414. Then you will find that the level 2 is on. Now this, if you click on to level 2, this level 2 is developed to indicate the effect of temperature on the measurement of pH. For that, select a sample. For example, I have selected lemon juice as sample. So this is lemon juice in which the pH electrode is immersed. Then the pH of lemon juice is 2.2. You will have to calculate what will be the output from a standard graph, or you can do it using the formula calculation for the output voltage E based on the material. So if you add here the value, it is 283.97. I click here. If the answer is correct, the value will. Now you can do it using various other materials and calculate the value. After you have done with one sample, level 3 is available to you. Click on to level 3. You will find you selected sample as fruit vinegar, and the output at 25 degrees Celsius was 224.81. Now if I expose it to different temperature, I have to calculate what will happen. Suppose I have exposed this electrode to 25 degrees Celsius. What will be the output? The output would be 224.81. If I do it for 38 degrees Celsius, output will become 234.61. That means as the temperature is increasing, the output millivolt is increasing. You can plot a graph which clearly indicates how the relation between temperature and pH is achieved. You can close this, and then you can go back and perform the experiment for some other liquid also or other sample also. So in summary, in level 1 we calibrated the pH sensor. In level 2 measured the pH value of a sample at 25 degrees Celsius, and in level 3 we found that if there is a change in temperature of the sample, what would be the output in millivolt. This is how all the 3 aspects of this experiment can be carried out. Now you can go to the other experiment which is called as conductivity. Now in case of a conductivity, there are 2 electrodes, positive and negative, and it is excited using an exciter AC voltage. Now select this experiment. For example, the sample is HCl and the concentration is 10%. The cell constant which you have selected is 1. Then what will be the specific conductance in Siemens at 25 degrees Celsius. You are supposed to calculate the value of this using formula. So this is the formula for specific conductance at 25 degrees Celsius. You can calculate the output in Siemens. You will select this for 3 sets of readings. Plot the graph. It clearly indicates that this is the relation between concentration in percentage versus conductivity in Siemens. So, in other words, as concentration in percentage is increasing, the conductivity in Siemens is also increasing. Now, this enables you to go to level 2 of this experiment, wherein we have a sample HCl. Specific conductance at 25 degrees Celsius is 0.65. We have selected concentration 5%. So if you give a temperature of 0 degrees, what will happen? You can calculate the output in Siemens by using this formula. So use this formula and calculate the output of conductivity sensor. After completing this, you can plot the graph. It will show you the relation between temperature versus conductivity. So in other words, as temperature is increasing, conductivity is also increasing. Then you can go to level 3. Level 3 is to know what happens in case of contamination. Now this contamination means the coating on the electrode. The assumption is half of this value is deposited on each electrode, and the dimensions which we have selected is the distance between the plate 1 centimeter, A is 10 centimeter, B is 0.1 centimeter, and selected contamination is 0.1 mm. What will happen to this value? So in other words, the modified cell constant will become 0.9. Previously it was 1, it will become 0.9. Specific conductance will become 0.65 and the modified specific conductance will become 0.59. Now you can calculate this using the formula and then cross check that your conductivity sensor with contamination is giving you modified cell constant or change in cell constant. This is how you can perform 3 stages of this experiment. In first stage, we talked about calibration. In second stage, we talked about the effect of temperature. And in third stage, we talked about the effect of contamination on the electrode. This is how you can perform the experiment.